In Space Tech, we are going to discuss about satellite communication. The maximum capacity of Indian launch vehicle, that is 4,000 kilogram. France is a long-term launching partner for India. It's over now. हमारा यहीं तक था. अब आप यूके लौट जाओ, इसलिए कि अब हमारे पास अपना खुद का सैटेलाइट है. When I say in-flight internet services, that means on board when you are flying at 35,000 feet. There also you can use the internet, right, after buying a particular subscription. In 2017, India emerged as one of the superpowered. SARC satellite is being launched by India for other country. It will be like India and Pakistan. और हमने पाकिस्तान से कहा कि देखो भाई, सैटेलाइट लॉन्च करना है, आतंकवादी लॉन्च नहीं करना है, और सैटेलाइट लॉन्च करने की कैपेसिटी तो हमारे पास है नहीं. मोर एंड मोर इकोनॉमिक एक्टिविटी विल गिव यू मोर रेवेन्यू, मोर जॉब अपॉर्चुनिटी. सेम थिंग इंडिया हैज डन. We are going to discuss space tech, right? And in space tech, we are going to discuss about satellite communication in detail. So we are basically in application part. And in application part, we are going to discuss satellite communication. If I take you to the last class coverage is latest communication satellite. What are the latest communication satellite? We'll talk about that. Got the point? The first one we can talk about is GSAT 24. GSAT 24. GSAT 24. So that is also known as the new name is CMS-02. CMS-02. Like I told you that ISRO has now started giving new names. Right. So GSAT 24 is the older name and the new name is known as CMS-02. But the problem is nowadays you have to keep this both name in the mind. Right. Chalo. So this satellite was launched in 2022 by Ariane rocket. Ariane rocket is not Indian rocket. Ariane rocket is basically French rocket, because this satellite is more than 4 ton. Now, if you have gone through all the space sector and all our launch vehicle, that you must be knowing the mightiest launch vehicle that India has developed so far is LVM-3. And LVM-3 can lift 4 ton only. So the maximum capacity of Indian launch vehicle is 4 ton. That is 4,000 kilogram. But this satellite was 4,200 kilogram. That is 4.2 tons. And many a time, when we are not able to launch our heavy satellite, we go for other countries' help. And France is a long-term launching partner for India. So you are right. This satellite was launched by French rocket Ariane 5. French rocket Ariane 5 in June 2022. In June 2022, right? June 2022. So French rocket Ariane 5, June 2022. Why? Because it is heavy, right? So region in the bracket you can write heavy satellite, and this is the weight of the satellite. Although you don't need to remember it. But one question might come in your mind, that why do we need to launch it from French rocket? We do it because we are not able to lift it, right? Second thing that we can talk about, that this rocket has got 24 Ku band transponder, right? So you can write this satellite has 24 Ku band transponder. 24 KU band transponder, right? It means that if it is having KU band transponder, all transponder are KU band transponder for DTH services. Which services? DTH services. Because just now we talked about that KU band are for DTH. KU band are for DTH, right? And you know one interesting story about it? That Tata Sky, like I told you in the last class, Tata Sky was the first DTH service in India, where Sky was UK company and Tata is Indian company. And now Tata Sky is joint venture. It's a partnership, right? But you might have realized that Tata Sky name has been changed now. And now Tata Sky is known as Tata Play, right? आप में से कितने लोगों के घर पे टाटा स्काई है और आपने रियलाइज किया कि टाटा स्काई का नाम टाटा प्ले हो गया? सो टाटा स्काई इज नाउ टाटा प्ले. तो अब क्या है ना, मैंने कहा था ना कि स्काई वॉज यूके बेस्ड कंपनी. दे केम इन इंडिया with their own satellite and they partnered with Tata. But now we are also a space superpower. So Tata ने इसरो से कहा कि अगर तुम मुझे एक सैटेलाइट लॉन्च करके दे दोगे जिसमें 24 KU बैंड ट्रांसपोंडर होगा तो मैं इसको पूरा खरीद लूंगा. ये पूरी की पूरी सैटेलाइट मैं ले लूंगा, है ना? entire satellite I'll get that. You get the point? और जब एक बार पूरी सैटेलाइट ले लूंगा, अगर एक बार पूरी सैटेलाइट ले लूंगा तो फिर क्या होगा? हम टाटा स्काई में से स्काई को टाटा बाय बाय बोल देंगे और फिर टाटा की पूरी ओनरशिप हो जाएगी. तो टाटा वांटेड टू से टाटा टू स्काई दैट स्काई इट्स ओवर नाउ, हमारा यहीं तक था, अब आप यूके लौट जाओ, इसलिए कि अब हमारे पास अपना खुद का सैटेलाइट है. तो दैट इज वाई टाटा स्काई हैज बिकम टाटा प्ले, राइट? बिकॉज स्काई वॉज गिविंग द सर्विसेज ऑफ इट्स ओन सैटेलाइट, बट नाउ टाटा हैज ओन्ड दिस सैटेलाइट. टाटा ने सैटेलाइट को खरीद लिया, राइट? तो you can write one more point. Entire GSAT 24 capacity, entire GSAT 24 capacity is being used by Tata Play. Tata Play DTH service. That means Tata has leased the entire GSAT 24. And once Tata has leased entire GSAT 24, then Tata can easily say Tata to Sky. है ना? ठीक है? तो ये भी ध्यान रखना कि अब हम एक मेजर प्लेयर है. दूसरा जो सैटेलाइट है लेटेस्ट में, सेकेंड सैटेलाइट दैट वी कैन टॉक अबाउट, दैट इज जीसैट सेकेंड सैटेलाइट, जैसे जीसैट 20 एंड न्यू नेम इज CMS 03. So older name is GSAT 20, new name is CMS 03. Right? And first thing you can write, it was launched by Falcon 9 of SpaceX USA. It was launched by Falcon 9. Right. Falcon 9 of SpaceX USA, Elon Musk, in November 2024. In November 2024. In November 2024. Right. So first thing you need to understand that this satellite was also very heavy. So 4700 kilogram heavy. And again, I'll tell you that we are not able to lift any satellite which are more than 4 ton. Right? Got the point? And this communication satellite is very important for India because it will provide internet connectivity to distant locations in India, and it will also provide very important in-flight internet services. That means now in India also you can get in-flight internet services. When I say in-flight internet services, that means on board when you are flying at 35,000 feet, there also you can use the internet, right, after buying a particular subscription, right? So you can write this communication satellite will provide data services and internet services. Data services and internet services. Data services and internet services to remote areas. To remote areas. Right? And to remote areas and in-flight internet connectivity. In-flight internet connectivity. In-flight internet connectivity. In-flight internet connectivity. Right. In-flight internet connectivity. So that's the main important thing. So in-flight internet connectivity. So now in aircraft also you can get that. Vistara has already started. Right? And one more thing you can write. This satellite has so in-flight satellite connectivity, you know, right? So you can write this satellite has Ku band transponders. What it has got? Ku band transponders. Ku band transponders. Right? Sorry, Ka band, not Ku band. I'm sorry. Ka band transponder. Ka band transponders. So three things. One is Falcon 9 SpaceX rocket. Why? Because it is 4700 kilogram heavy. And this is the first time we have used this Falcon 9. This is reusable launch vehicle, right? In-flight internet services, we are going to provide with that, and we have already started. And for that, it has got Ka band transponder. Any problem? Hello. These are the latest communication satellite. इसके बाद हमने कोई communication satellite launch नहीं किया है. तो last communication satellite that we have launched was in November 2024, right? Next one is other important communication satellite. Other important communication satellites. So we'll talk about some other important communication satellite. Okay? And these are the older one, but nowadays we are talking about it. Right? So what are those other important communication satellite we are going to talk about? For example, let's say there is something called, the first one we'll talk about, GSAT 7. GSAT 7. And we have launched GSAT 7 in 2013. So 2013 was a time when we launched it. But why this 2013 satellite GSAT 7 is important now? अभी क्या है? Right? तो इसलिए क्योंकि ये this is a defense communication satellite for नेवी. ये नेवी का डिफेंस कम्युनिकेशन सैटेलाइट है, राइट? सो दिस डिफेंस कम्युनिकेशन सैटेलाइट फॉर नेवी, एंड नेवी हैज रीनेम्ड इट, राइट? renamed by Navy, and Navy call it Rukmini, right? So ISRO will tell GSAT 7 and Navy will call it Rukmini. So Navy has got a Rukmini satellite. A Rukmini satellite is nothing. It's a long back, 12-year back. ISRO launched one satellite that is called GSAT 7, and it has been dedicated to Navy. The entire satellite capacity is being used by Navy, so that Navy can connect to all the ships and aircraft carriers and the fighter planes in the vast Indian Ocean, right? Vast Indian Ocean. You got the point? And if you have gone through current affairs, then there is one more thing that we came across, that in future, GSAT 7R will be launched. In future, here I am writing GSAT 7R will be launched as replacement. So this is going to be, finished. ये खत्म हो जाएगा तो इसके जगह पे रिप्लेसमेंट जाएगा, GSAT 7R, R for replacement, and that is in news. अब नेवी को दे दिया तो बाकी को भी दो. तो फिर सेकेंड लॉन्च हुआ, सेकेंड सैटेलाइट दैट वाज लॉन्च्ड, हियर आई एम राइटिंग, दैट इज कॉल्ड GSAT 7A, and GSAT 7A was launched in 2018, right? That is in 2018, and this is again defense communication satellite for Air Force, right? And it was also renamed as Angry Bird. What Air Force call it? Angry Bird. So Angry Bird is a name, right? So GSAT 7A 2018 defense communication satellite that was launched, and then it was given to Navy, right? And given to Air Force, और Air Force ने इसका नाम क्या रखा? Angry Bird, right? और इसका 30%, right? That is what you need to understand. 30% capacity for army. So army is sharing, although 70% is being used by Navy. 70% is being used by Navy, but 30% capacity of this is being used by the army itself, because army has not get its own satellite till date, और वो भी लॉन्च करने वाले हैं. कौन सा सैटेलाइट लॉन्च करेंगे आर्मी का? तो आर्मी की सैटेलाइट जो थर्ड होगी, हियर आई एम राइटिंग, लुक एट दिस, GSAT 7B, right, and that will be in future. In future, it's a planned, and this will be defense communication satellite for army. So our defense minister Rajnath Singh has already announced it, and he said that okay, till date Navy has got one, that is called Rukmini. Air Force has got one, that is called Angry Bird, and 30% capacity of Angry Bird is being used by army, but army will get its own satellite in coming time. So maybe this year or next year we are going to launch. So now you have 3 satellites, right? Any problem with that? Okay. One more very important satellite that we need to understand, and that satellite that we can talk about, right? एक सैटेलाइट और है जिसके बारे में हम बात करेंगे, और वो है फोर्थ सैटेलाइट, दैट इज कॉल्ड GSAT 9. Okay, GSAT 9, and GSAT 9 was launched in 2017. But this satellite is little different. Why it is different, I'll tell you. Now 2017, India in 2017, a space segment of India in 2017. In 2017, India emerged as one of the superpower in a space sector. And you know that India is also active in regional politics, geopolitics, because we have 2 countries who are our neighbors, but we are not having very good relationship with them. One is China, another is Pakistan. And we have to counter them. And to counter them, we need to have support of the other country who are nearby us, right? South Asian country. What we call it? South Asian country. And to, keep all the South Asian country at one place, there is something called SAARC. Anybody know about SAARC? SAARC पता है? SAARC. UPSC aspirants, tell me, are you aware of something called SAARC? So SAARC is South Asian Association for Regional Cooperation. In this SAARC, South Asian countries are there. India, Pakistan, Afghanistan, Bangladesh, Sri Lanka, Bhutan, Nepal, Maldives. These all countries are there. And if you look at the SAARC countries, so all these countries, India, Sri Lanka, Bangladesh, Pakistan, Nepal, Bhutan, Maldives, Afghanistan. So these are South Asian countries, and you can see in this SAARC country, SAARC headquarters is in Kathmandu, right? And you know that in this SAARC country, India is the biggest one. Not only in terms of, geographical coverage, but also in terms of technology, also in terms of, money, GDP, economy. So among 7 members of SAARC, among 8 members of SAARC, India is big brother. The biggest brother is India. In other words, we can say that India is giver, the rest other countries are taker. India can provide and the other country will accept, right? So in 2017, India decided that let's launch a satellite, GSAT 9, and this satellite will be dedicated to SAARC nation. This communication satellite will be dedicated to SAARC nation, right? And we'll call it, India wanted to give a name and India wanted to give the name SARC satellite. SARC sat. That was the name India wanted to give. And India was all clear that, okay, we are powerful country, we are having lots of money. So we can launch a satellite, communication satellite. And the name of this communication satellite will be SARC satellite. And services of this SARC satellite will be available to all SARC nation. So all SARC nation will use this satellite free of cost. India won't charge a single penny for it. You got my point? For normal civilian communication needs, this satellite will be open for all. Bhutan, Sri Lanka, Maldives, Pakistan, Afghanistan, they will be able to get that. है ना? But पाकिस्तान ने कहा, इंडिया ने कहा कि सार्क लॉन्च करेंगे, बट पाकिस्तान ने कहा कि नहीं, ऐसा नहीं. अगर आप सार्क सैटेलाइट यूज करना चाहते, इफ यू वांट टू लॉन्च सार्क सैटेलाइट, इफ यू वांट टू यूज सार्क नेम इनटू इट, तो ये इंडिया सिर्फ नहीं करेगा, ये इंडिया पाकिस्तान मिलकर करेगा. दैट मीन्स लॉन्च ऑफ दिस सैटेलाइट विल नॉट बी जस्ट इंडियन लॉन्च. Pakistan suggested that, okay, I am also big country. I also got independence along with India. So it won't be like, SARC satellite is being launched by India for other country. It will be like India and Pakistan is launching SARC satellite for other country. Right? और हमने पाकिस्तान से कहा कि देखो भाई, सैटेलाइट लॉन्च करना है, आतंकवादी लॉन्च नहीं करना है ना? और सैटेलाइट लॉन्च करने की कैपेसिटी तुम्हारे पास है नहीं, क्योंकि तुम, पाकिस्तान से इंडिया ने कहा कि क्योंकि तुम इंडिया के स्पेस प्रोग्रेस से 30 इयर्स बिहाइंड हो. राइट? 30 साल पीछे हो. और जाहिर सी बात है, लॉन्च क्या करना है? सैटेलाइट. किससे? रॉकेट से. टेररिस्ट लॉन्च नहीं करना है. लेकिन पाकिस्तान को भी पता था कि इंडिया नहीं मानेगा. राइट? लेकिन पाकिस्तान ने सिर्फ ये अड़ंगा लगाया. अड़ंगा समझते हैं? ये बैरियर क्रिएट किया. राइट? और बैरियर क्रिएट करके, बिकॉज पाकिस्तान नेवर वांटेड दैट इंडिया शुड यूज सार्क नेम, तो वो सार्क नेम इंडिया को यूज करने नहीं देना चाहता था. तो हमने सार्क नेम नहीं यूज किया. वी डिडंट यूज द सार्क नेम. हमने कहा कि नो पाकिस्तान एट ऑल, वी वोंट entertain Pakistan, rather we called it South Asian satellite. South Asian satellite. And now this South Asian satellites benefits are available to all SARC nation except Pakistan. है ना? So सिर्फ पाकिस्तान को छोड़ के बाकी सब यूज कर रहे हैं. पाकिस्तान क्यों यूज करेगा? So it was fight for name only. You need to understand it was a part of a space diplomacy. It was part of a space diplomacy. Why? Because Pakistan wanted to stop India to use the name SARC. Right? And if India wants to use the name SARC, then Pakistan pressurized India that keep me as a partner, so that this country would understand that, okay, India and Pakistan together helping them. So India will not get full credit of it. Right? You get my point? India will not get full credit of it. So India ने कहा कि no problem. What's in the name? What's in the name? Shakespeare ने कहा what's in the name? So we'll drop the SARC name. Rather we'll put it like South Asian Satellite. Equally good name. Right? And then it's all done. So you can write. तो पाकिस्तान को हमने इंक्लूड नहीं किया. एंड यू कैन राइट. सो जीसेट 9 सार्क सैटेलाइट लिख के काट देना, और फिर साउथ एशियन सैटेलाइट, एंड देयर यू कैन राइट दिस इज पार्ट ऑफ space diplomacy. This is part of a space diplomacy. This is part of space diplomacy. Full stop. This satellite's capacity is available to all SAARC nation all SAARC nation except Pakistan. Right? So this is our communication satellite discussion, है ना? कोई दिक्कत? So let's move on to the next topic now. Communication satellite is done. And after this communication satellite, what we are going to add in here, we can add one more topic because we have done. We'll talk weather satellite. Weather satellite. So one by one, we are completing this application part. So let's move on to the weather satellite. If you have any problem, you can ask. The weather satellites of India, we'll talk about that. And I'll tell you one thing, that India is one of the most advanced country in the weather satellite segment also, right? And we put weather satellite in geostationary orbit, and the payload of this satellite is sounder and imager, right? We'll talk about that. So you can write. India has advanced weather satellite. India has advanced weather satellite. India has advanced weather satellites. Right. Full stop. Weather satellites are placed in geostationary orbit. Weather satellites are placed in geostationary orbit. Weather satellites are placed in geostationary orbit. Right. And then you can write payload of weather satellites are sounder and imager. Payloads of geostationary satellites are sounder and imager. Payload of geostationary satellites are sounder and imager. Geostationary, yes. Sounder and imager. Now, what does sounder and imager can do? So, one by one you can write. So, sounder is very unique. Sounder is a payload which can measure, which can collect data related to temperature and humidity from different height. So, it can provide you vertical profile of temperature and humidity. That what is temperature and humidity at a particular height it can give you. Got the point? In geography, we talk about that climatology is a chapter in geography. And in climatology, we all know that temperature and humidity are two very important things, right? Are two very important things. Got the point? So sounder and imager. Sounder and imager. So sounder will measure. Sounder will measure. What it will measure? It will measure vertical profile of temperature and humidity. That what is temperature and humidity level at different height. 100 मीटर पे टेम्परेचर क्या है, ह्यूमिडिटी क्या है, 1 किलोमीटर पे क्या है टेम्परेचर ह्यूमिडिटी, 2 किलोमीटर पे क्या है. तो अर्थ से लेके और अपर एटमॉस्फेयर सब कॉन्टिनेंट. सो यू राइट इमेजर के बारे में लिखिए. इमेजर, दिस इज अ कैमरा, दिस इज अ कैमरा which provides this is a camera which provides image of Indian subcontinent, image of Indian subcontinent to locate image of Indian subcontinent to locate cloud, to locate cloud, to locate cloud. And cloud can give you lots many information, you know that. To locate cloud, isn't it? I'll show you. I can show you that what this camera can do, right? So if I simply go with InSat image, अच्छा चलो आगे करते हैं. Right, we'll talk about later. Right, weather satellites of India. Right, we'll talk about that. So one thing which is worth mentioning is METSAT 1. METSAT 1 was renamed as Kalpana 1. Kalpana 1, right? And that was in 2002. It's not there with me, with us. Why? Because it was long back satellite, but it is unique because it was first dedicated weather satellite. First dedicated weather satellite. Initially it was named as METSAT, but because Kalpana Chawla demise. Kalpana Chawla was American astronaut of Indian origin, and due to demise of Kalpana Chawla, in the honor of Kalpana Chawla, we renamed it as Kalpana 1. But it's not there with us anymore. Satellite has already completed its lifespan and it's all gone. At present, we are having these satellites. जो अभी सैटेलाइट है वो कौन कौन से हैं? तो सैटेलाइट है हमारा InSat, InSat 3D. Then the third one we are having InSat 3DR and InSat 3DS. 3DS. So 3D, 3DR, 3DS. Right? So that was in 2013. Dates are not important. This was in 2016 and this was in 2024. Right. So these three satellites, 3D, 3DR, 3DS. Got it? And the present day weather satellite that we are having is 3D, 3DR and 3DS. पहले के InSat में और अभी के InSat में क्या अंतर है? The InSat we started long back. It was multi-purpose. But InSat we are having right now is not multi-purpose. Now it is right. ओके ठीक है, अब देखो, नाउ इंडिया इज वन ऑफ द मोस्ट पावरफुल कंट्री in terms of space technology. And not only that, India has got advanced weather satellites, and we are having advanced weather satellite like any other country. We match the capability of America and Russia and Canada and France. We match their capability. So once you have lots of power, because you are one of the most powerful country in terms of space technology, so once you have more power, then power will not come alone. Power will bring responsibility. You get my point? So whenever you get power, power is never coming alone. Power will always give you responsibility. India is part of international satellite based search and rescue system. International satellite based search and rescue system. Full stop. Our advanced weather satellites are our advanced weather satellites are having search and rescue payload for it. Having search and rescue payload for it. Our advanced weather satellites are having search and rescue payload for it. So our weather satellites is not only for weather, it is also having search and rescue payload. You got the point? So that is one point you need to keep in. Now we are moving on to our next application. And the next application that we can talk about is navigation satellite, or let's say satellite navigation. Satellite navigation. You got the point? Satellite navigation, right? Satellite navigation. ये है मामला, right? So again we have to modify our topic list, क्योंकि देखो हम कितने बढ़िया से पढ़ रहे हैं, और इसमें हम एक और पॉइंट ऐड कर रहे हैं, सैटेलाइट navigation. Okay, so we are adding satellite navigation in application part. Got it? And I'll tell you one thing. Okay, have you ever used satellite navigation? Have you ever used satellite navigation? Ayush ne kaha recently India rescued Chinese vessel. Yes, we have done it many a time. क्या अभी कभी आपने सैटेलाइट नेविगेशन यूज किया है? सैटेलाइट नेविगेशन तो यूज नहीं किया होगा, लेकिन सैटेलाइट नेविगेशन बेस्ड गूगल मैप यूज किया है आपने. सो वॉट एवर गूगल मैप कैन टेल यू, दैट इज नथिंग बट द सैटेलाइट नेविगेशन. ये गूगल मैप जो है ना, दैट्स नॉट सैटेलाइट नेविगेशन. दिस इज सैटेलाइट नेविगेशन बेस्ड एप्लीकेशन. सो गूगल अपने बैकएंड पे जीपीएस से सिग्नल लेता है. GPS is world's most popular satellite navigation. You get the point? World's most popular satellite navigation. That is GPS. Right. So what is satellite navigation? Satellite navigation means that through satellite navigation, we can determine relative position of any object. Right. जैसे गूगल मैप को जब आप ओपन करते हो, वेन एवर यू ओपन अ गूगल मैप लाइक दिस, लाइक द वे आई एम ओपनिंग माई मैप. तो मैप जैसे ही आपने ओपन किया मैप्स, सो मोमेंट आई ओपन द मैप, आई गेट दिस काइंड ऑफ डॉट. यू कैन सी दिस काइंड ऑफ डॉट वी गेट, अगर आपको दिख रहा हो तो, बाय माइक्रोवेव्स, बाय माइक्रोवेव्स, है ना। तो वो कैसे करता है हम लोग डिस्कस करेंगे, हाउ इट कैन डू, विल डिस्कस इट, राइट। सो लेट्स से, अगर मैं एक एग्जांपल दूं कि अगर मुझे, आई एम इन ए स्टूडियो इन दिल्ली, मुखर्जी नगर, राइट, and I'm taking this class from that particular place, and I have to if I have to explain my position in this room, then you are not able to see the entire room. All you can see is this board up to here to here, right? That is your vision. And if I go anywhere, इसके अगर मैं बाहर चला जाऊं ऐसे, तो आपको नहीं पता मैं किधर गया, पता है आपको, नहीं पता है ना। बट इफ आई वांट दैट यू शुड बी नोइंग वेयर एग्जैक्टली आई एम, तो फिर मैं आपको सबसे पहले तो इस रूम का मैप भेजूंगा, है ना। तो मैंने आपको इस रूम का मैप भेज दिया कि दिस इज द मैप ऑफ दिस रूम, ये रूम का एक मैप है, और ये वाकई में ऐसे ही है, ये गेट है, राइट। दिस रूम इज लाइक दिस, एंड दिस इज द बोर्ड, ये बोर्ड है, दिस इज अ बोर्ड, हियर इज अ कैमरा, राइट। And then I'll say that I'm standing, I'll simply say that I'm standing 1 feet away from the board. तो 1 feet away from the board का मतलब कहीं भी हो सकता हूं इधर इस लाइन में, ये x एक्सिस मान लो, I can be anywhere in this line because I'm saying 1 feet away from the board, so x axis, right? But I can be anywhere in this line, I can be here, I can be here, I can be here, I can be here. You want my pinpointed location. Then I can say that, okay, I am standing 1 meter or 2 meter away from this wall. इस wall से 2 मीटर के दूरी पे। तो हमने एक और लाइन खींच दी, और एक और लाइन ये खींच दी कि चलो इस वॉल से 2 मीटर की दूरी पे, आई कैन बी एनीवेयर इन दिस लाइन। बट अब क्या है ना, इससे मैं 1 फुट की दूरी पे हूं और इससे 2 मीटर की दूरी पे हूं, तो ये मेरी पोजीशन हो गई। This is y-axis, and then there is a platform on the floor. I am standing on that platform, so I can say that, okay, I am 6 inch above the ground, 6 inch above the ground. So I can tell you one more data that I am 6 inch above the ground. अब इसको मैं दिखा नहीं सकता, but 3 dimension में, तो हमें चाहिए 3 axis, x, y and z, x, y and z. 3 axis. It's a 2D, but 2D can tell that where exactly I am. But again, I have to tell my altitude, where I am, कितना ऊपर हूं. So for that, I have to get the 3rd dimension also. And 3rd dimension is x axis, 1st dimension, y axis, and then z axis. Similarly, if you have a car, ये अर्थ है, ये अर्थ है, और अर्थ पे आपके पास एक कार है, एंड यू आर हैविंग अ टेस्ला कार, साइबर ट्रक, राइट। सो यू आर हैविंग अ साइबर ट्रक कार, राइट। जो भी था, है ना। और इस कार में एक ट्रैकर लगा है, जीपीएस ट्रैकर, एंड इफ यू वांट टू लोकेट द पोजीशन ऑफ दिस कार, है ना, तो उसके लिए सैटेलाइट है। जैसे देखो ये सैटेलाइट है, दिस इज 1 सैटेलाइट, सैटेलाइट नंबर ए, सैटेलाइट नंबर बी, देन देयर इज सैटेलाइट नंबर सी, right? Let me relocate the satellite. Okay, I cannot relocate that anyway. So 3 satellites are there, and this satellite will send a wave, and it will send it, it will get it back. दिस सैटेलाइट इट ऑल्सो सेंड अ वेव, ये भी भेजेगा, ये भी ले लेगा, और ये भी सैटेलाइट एक वेव भेजेगा. वेव विल कम एंड गो. नाउ दिस वेव इज माइक्रोवेव. विच वेव इज दैट? माइक्रोवेव. और उसकी स्पीड क्या होती है? 3 into 10 to power 8 meter per second. Everybody know about it? Microwave is a EM wave, and any EM wave will travel with a speed of 3 into 10 to power 8 meter per second. 3 lakh kilometer per second. और याद होगा आपको कि नेविगेशन सैटेलाइट का जो पेलोड है उसमें एटॉमिक क्लॉक था. किसको किसको याद है? एटॉमिक क्लॉक किसको किसको याद है? एटॉमिक क्लॉक, राइट? So how many of you know that navigation satellite has got atomic clock as payload, right? And what atomic clock can do? Atomic clock can do precise time keeping. बहुत ही precise time keeping करता है. सेकेंड के लाख पार्ट तक, मिलियंस पार्ट तक उसको कैलकुलेशन करना आता है, राइट? अब देखो, सैटेलाइट ए से माइक्रोवेव आया और गया, 3 लाख किलोमीटर पर सेकेंड की स्पीड से आया और गया. सो वी नो द स्पीड, और एटॉमिक क्लॉक ने टाइम निकाल लिया. जाने में कितना टाइम लगा, वापस आने में कितना टाइम लगा. तो स्पीड मल्टीप्लाइड बाई टाइम is equal to distance, isn't it? Are you aware of this simple calculation? Speed multiplied by time is equal to distance. Speed, we know that microwave will travel with a speed of 3 lakh kilometer per second. An atomic clock can measure the fraction of second, the millionth part of the second it can calculate. So it can give you the precise time of it. Speed multiplied time, you get the distance. That means A सैटेलाइट ने कैलकुलेट कर लिया कि ये कार A से कितनी दूरी पर है, B से कितनी दूरी पर है और C से कितनी दूरी पर है. जैसे मैंने कहा कि इस कमरे में मुझे अपनी पोजीशन बतानी हो तो आई नीड 3 एक्सिस. X एक्सिस से कितनी दूर हूं, Y एक्सिस से कितनी दूर हूं और Z एक्सिस से कितनी दूर. Similarly, if 3 satellites can communicate with this car, and this 3 satellite will communicate, not only communicate, it will just measure the relative distance from A, from B and from C. हाँ, सौरभ, स्पीड ऑफ लाइट ही होती है. इस लाइट भी ईएम वेव ही तो है, इसलिए तो एनसीईआरटी पढ़ना जरूरी होता है सौरभ, है ना? तो लाइट की स्पीड, लाइट इज ईएम वेव, माइक्रोवेव इज ऑल्सो ईएम वेव. तो जैसे मैंने कहा कि मुझे या आपको आप अपने कमरे में हो, सौरभ अपने कमरे में है, और सौरभ को अपने कमरे में अपनी पोजीशन मुझे बतानी है. तो सौरभ सबसे पहले अपने कमरे का मैप भेजेगा और फिर बोलेगा कि मैं अपने लेफ्ट वाले वॉल से कितने डिस्टेंस पे हूं, मैं अपने सामने वाले वॉल से कितने डिस्टेंस पे हूं और मैं जमीन से कितना ऊपर हूं. एनी 3 पॉइंट यू सेलेक्ट इन योर रूम and then you just find the distance. I'll just draw it and I'll get that, right? Similarly, any 3 satellites which are placed in the Earth's orbit will communicate with this car, and because we know that the microwave speed is 3 lakh kilometer per second and time taken will be calculated by atomic clock, distance will be coming up, right? ठीक है. और अगर आपको इस कार की स्पीड भी निकालनी है तो इसमें एक और चीज होगा. अगर स्पीड निकालनी है कार की तो आपको 2 और सैटेलाइट लगाने पड़ेंगे. सैटेलाइट ए बी सी, तो एक डी भी लगाना पड़ेगा और एक सैटेलाइट ई भी लगाना पड़ेगा. एंड व्हेन दिस 2 सैटेलाइट विल कम्युनिकेट, देन यू विल गेट द स्पीड ऑल्सो, स्पीड एंड डायरेक्शन, राइट? लेकिन अगर आपको सिर्फ पोजीशन निकालना है, ओनली पोजीशन यू हैव टू फाइंड आउट, वेयर इज माई कार, only position, not speed, not direction, then 3 satellite is needed, minimum 3. और अगर स्पीड और डायरेक्शन भी निकालना है तो मिनिमम 5. So payloads of navigation satellite. So payloads of navigation satellites, and there we have two payloads. One is called navigation transponder. Navigation transponders. And then we have atomic clock. Atomic clock. So two things are there. We'll talk about that. Right. So atomic clock do what? For precise time keeping. Time keeping means time measurement. Because you are dealing with the speed of 3 lakh kilometer per second. If the speed is 3 lakh kilometer per second, then your clock should be very precise. Because if there is an error of 0.1 second, then this error will amplify. 1 सेकेंड में 3 लाख किलोमीटर का कैलकुलेशन है, तो अगर 1/10 सेकेंड की भी एरर होगी तो 30,000 का एरर आएगा. दैट्स वाई वी नीड एटॉमिक क्लॉक. एंड दिस इज नेविगेशन ट्रांसपॉन्डर फॉर माइक्रोवेव कम्युनिकेशन with what? Tracker, or let's say receiver. With receiver. Right? So these two things are there. Got it? If there is any problem, we'll discuss about satellite navigation system, right? So satellite navigation systems. What are the satellite navigation systems that we are having around us? And there could be two types. We can divide into two parts. One is called global. Global means the coverage is entire globe. And another one is regional. So global and regional. Two things are there. So global and regional. Global one, if I can count in, if I can tell you, then the global one that we are having, the first is GPS. The second one is GLONASS. The third one is Galileo. And the fourth one is compass. Compass is also called Baidu 2. So GPS, GLONASS, Galileo and compass. Right? GPS is of USA. This is of Russia. This is of European Union. And this is of China. Chinese name is Baidu 2. Global name is compass. So all over world, 4 global satellite navigation systems are there. Right. तो ग्लोबल का मतलब क्या होगा कि इन कंट्री का रीच पूरे के पूरे ग्लोब पर है. दे कैन ट्रैक एनीथिंग, एनी रिसीवर ओवर द एंटायर ग्लोब. अर्थ पे कहीं भी ट्रैकिंग कर सकते हैं, है ना. लेकिन रीजनल भी है. और रीजनल कौन कौन से हैं? तो लेट्स लुक इनटू द रीजनल पार्ट. एंड इफ वी टॉक अबाउट रीजनल, देन द फर्स्ट थिंग वी कैन टॉक अबाउट इज NaVIC. So the first I would like to talk about NaVIC. Second one is QZSS. And third one is called Baidu 1. So Baidu 1 is of China and China has upgraded it. QZSS is called Quasi Zenith Satellite System. And this is of Japan. And this is our navigation with Indian constellation. Constellation means group of stars, but here constellation means group of satellite, and this is of India. Needless to say, Indian word is already there. So NaVIC, QZSS, and Baidu. And you know that Baidu has upgraded it. So this has been upgraded. Upgraded. So Baidu 1 is upgraded to Compass and Baidu 2. Got the point? But we have to learn something more about it. What we can learn more about this, that if your system, here I am writing, if your system is global, then minimum satellite needed is 24. 24 plus backup. 24 is a minimum satellite you need to have. Minimum satellite that you need is 24. None of them are having less than 30 satellite, because 24 is minimum you need. तो 24 तो चाहिए ही चाहिए, बैकअप भी चाहिए, तो 30-35 satellite all of them are having. And the orbit is MEO. Which orbit is that? MEO. So that global. If it is global, then these two things should be there. Right. Here, if it is regional, then minimum satellite should be 3 to 5. 3 to 5. And orbit should be GSO. Orbit should be GSO. 3 to 5 GSO. Backup, yes, backup satellite plus backup satellite. Right. Then why minimum 24 is needed? Because if 24 satellite is moving all over the world, then you can get at least 5 satellite at every places. है ना? If you look into the global satellite, I can show you that how global satellite looks like. First of all, you have to write that. इसको लिखो. So NaVIC is navigation with Indian constellation. Like I told you, that's a full form. Although the old name, that is what the ISRO has given, that was IRNSS. Right. So that was the older name, IRNSS, which stand for Indian Regional Navigation Satellite System. Satellite system. So that's the older name. Right. Now, what is NaVIC? So NaVIC is SBNS. So in one word, we have to say what is NaVIC. So this NaVIC is SBNS. That is called Satellite-Based Navigation System in technical term. So that is India's satellite-based navigation system. So NaVIC is SBNS. GPS is also SBNS. Right. So this is also known as satellite-based navigation system. Right. What is the coverage? So because it is regional, the coverage is India and 1500 kilometer. from border. So from Indian border, the coverage is 1500 kilometers. So entire India will be covered and 1500 kilometer around that will be covered also, right? If we talk about accuracy, that means how accurate the signal could be. So it's 10 meter on land and 20 meter on water. In ocean, you can write in ocean. Because when you talk about 1500 kilometer from border, so large part of ocean would also be there. So accuracy is 10 meter on land, 20 meter in ocean, and average accuracy, average is 15 meter. So that is what we know about it. Average is 15 meter, right? Now, satellites. What are the satellites that we have? So satellites that we have, total 7 satellites. So 7 satellites would be needed. Out of 7 satellites, 3 satellites in geostationary orbit. Geostationary orbits. And 4 satellites in geosynchronous orbit. Got it? So 3 and 4. Like in the last class, I have already given you, right, the coverage and the satellite part, right? If you remember, right? Even today also I can show you, don't worry. So satellite, 7 satellite total. Accuracy is 10 meter on land, 20 meter on ocean. And one more thing that you need to understand, what kind of payload it has, right? So payload. So next one is payload. So payload, they have 2 types of payload. So one is navigation transponders, and the second payload that is very unique is rubidium atomic clock. And according to the speech given by V. Narayanan, now we are able to make atomic clock. Earlier we were not able to make atomic clock. Now we can make it, right? So these are the things. Now NaVIC navigation system, it can provide you 2 type of navigation signals. Navigation signals are of 2 types, because you know that any navigation satellite system can be used in civilian application and it will have military application also. So civilian and military, 2 types of applications are there, right? So what is there? To bifurcate it properly, what we do, that we separate it, right? So here we can say NaVIC signals or services. NaVIC services. So NaVIC service, it can be divided into 2 parts. 2 parts it can be divided into. One is called a standard positioning signal. What we call it? The first is called a standard positioning signal. That is called SPS. What we call it? SPS. Standard positioning signal. Now what is this SPS? When I say SPS, it simply means one thing, that it is for civilian application. Civilian application, right? It is open signal. When I say open signal means it is non-encrypted. Non-encrypted. encrypted. It's not coded. It's non-encrypted. So civilian application, non-encrypted, right? And available for normal civilian application and commercial application, right? So also available for commercial application, right? So normal civilian application and commercial application, open signal, non-encrypted, nothing, no free, easy to get. Anybody can get it. But then there is another one, and that is called second one, that is called precise positioning signal, PPS, or it is called also called restricted signal, RS. So short forms are there: precise positioning signal, right, or restricted signals. Whatever you want to say, you can call it. Both you have to remember, right? Moreover, what is special about this signal? Now this signal, as we can say, it is precise and restricted. So restricted means one, it is accurate, more accurate, multi-purpose and encrypted. Nobody can get it unless you have code for it. And then these codes will be available only to defense and strategic sector. So you cannot get it, right? So this signal is for defense and strategic uses, right? And what is the unique part of this signal? It is encrypted, accurate, more accurate, you can write, more accurate and multi-purpose. Lots of information it will hold. But remember one thing, the best thing about it, that it's a defense and strategic uses. Army will use it. है ना? So army will use it. I mean, we civilians cannot use it because it is for, it is for army application only. Any problem with that? Is there any problem? So that is about our NaVIC services. Two type of services are. So this is the coverage area. So it is covering entire India, and then you can see there is a dotted line passing through, and the most important thing, right, the most important thing, that it is covering Pakistan and China, and we wanted to cover them both because these two guys need to be covered, right? These two guys who are our neighbors, but they are not good neighbors, and we need to cover them in our NaVIC navigation coverage, so that whenever it requires, we can teach them lesson. Recently, we taught the lesson to Pakistan, right? Right? Obviously, China also covers the entire India, an entire globe rather, and Pakistan is using Chinese navigation system for their own defense application. But India do not need to rely on any other country, right? India has got its own navigation system, and when we have our own navigation system, we are at peace, right? So obviously, Pakistan and China, these are the two important area that we wanted to cover, so that our missile can hit bang on the target, है ना? ठीक है? Similarly, can you see this satellite constellation? right? So 7 satellites are needed, and the coverage that you are getting, how many satellites are needed? 7 satellites. So 7 satellites of NaVIC. 7 satellites of NaVIC. Okay? Any problem with that? So 3 satellites, 1, 2, and 3. 3 satellites at GSO, geostationary orbit, and these two are in geosynchronous orbit. Right? The topic we'll call it NaVIC Satellite. है ना? अब तो एनर्जी ठीक है ना सुहानी? NaVIC Satellite. So if we go with the NaVIC Satellite, then this NaVIC Satellite can be divided into 2 parts. One is called first generation satellite, and that is called IRNSS satellite. What we call it? IRNSS satellite. Right? And then this is the upgrading. We are upgrading it into second generation satellite, and that is called NVS satellite. What we call it? NVS satellite. You got the point? So first generation satellite and second generation satellite. तो फर्स्ट जनरेशन सैटेलाइट हमारा जो है ना वो IRNSS सैटेलाइट है जो हमने लॉन्च किए थे, बहुत सारे लॉन्च किए, और सेकेंड जनरेशन सैटेलाइट है जो हमारा, उसका नाम है NVS, है ना? तो देखो इसमें क्या है. हियर आई कैन टेल यू दैट in this system I can tell you that we have already launched 9 satellites, right? So here one point we can write 9 launches but 7 satellite in orbit. इसका मतलब क्या हुआ? 2 फेल हो गया. 7 satellite in orbit. So 9 launches were there. Out of 9 launches 2 become failure, right? और अभी 7 satellite in orbit है. यहां पे क्या है? 2 launches, right? But 1 satellite in orbit. यहां पे भी एक सैटेलाइट फेल हो गया. मतलब मुझे तो कई बार नाविक के लक्षण ठीक नहीं दिखते हैं, है ना? मुझे नाविक के चाल चलन ठीक नहीं दिखते हैं. कई बार होता है ना, लक्षण ठीक नहीं दिख रहे हैं. क्या तरीका है ये? 7 चाहिए था, 9 आपने लॉन्च करवाया, 2 फेल हो गया. उधर हमने सोचा कि चलो और बेहतर करते हैं, 2 लॉन्च किया, 1 फेल हो गया. तो ये गड़बड़ है, मुझे तो अच्छा नहीं लगता है, राइट? ठीक है. अच्छा, सबसे इंपॉर्टेंट क्या है कि ये लाइट वेट सैटेलाइट था. सो इट वाज लाइटर और लाइट वेट सैटेलाइट launched by PSLV. Because when we planned NaVIC, जब नाविक प्लान किया हमने कारगिल के बाद, तो हमारे पास PSLV ही था. We didn't had GSLV because cryogenic was not there with us. So we were forced to launch the lighter satellite because PSLV can lift up the lighter only, है ना? तो वो लाइटर को ही लिफ्ट अप कर सकता है, राइट? एक और बात हम लिख सकते हैं इसी में कि इसमें जो ट्रांसपॉन्डर है, इसमें जो पेलोड है, सो पेलोड में आपने पढ़ा था नेविगेशन ट्रांसपॉन्डर. सो नेविगेशन ट्रांसपॉन्डर आर 2 types, L5 and S band. So payload is S band and L5 band transponder, right? And another payload is rubidium atomic clock. ये तो याद ही हो जाएगा, इतनी बार बोला atomic clock. But this atomic clock was imported. import it. That means we were not able to develop it at that time. सोचो हमने नाविक के साथ कितने कॉम्प्रोमाइजेस किए, हमें चाहिए ही चाहिए था. We never wanted to have the Kargil like situation once again, right? So what we have done, हमने कहा कि ठीक है PSLV से लॉन्च करो, छोटा सैटेलाइट बनाओ, हल्का बनाओ, और मीडियम एटॉमिक क्लॉक नहीं है तो एक काम करो बाहर से लेके आओ, है ना. लेकिन अभी हम सबको अपग्रेड कर रहे हैं. इधर अपग्रेड क्या कर रहे हैं? नाउ दिस इज हेवी सैटेलाइट launched by GSLV Mark II. Heavy satellite launched by GSLV Mark II. That's one thing, right? लेकिन अगर हेवी सैटेलाइट है, GSLV Mark II है, तो हेवी क्यों है? Why it is heavy? Because we have changed and upgraded the payload. Obviously, satellite upgradation means the payload upgradation. The main functional part of the satellite is payload itself. So if you upgrade the satellite, you are basically upgrading the payload, right? So here, payload. So what is there in the payload? Obviously, we have S band, L5 band, but then additional L1 band. Now this is additional, I am underlining it. L1 band transponder, right? So additional transponder L1 band has been added, and that's the important one. And the other payload that we can talk about, rubidium, atomic clock, that is your now indigenous, self-made, right? So that is India made. That is why ISRO chief has been praising about India, that now atomic clock we are making. So what are the two differences and three differences? One, it is heavy. Second one, that it is heavy because we have added one additional transponder that is called L1 band, and one more self-reliability, self-reliance we have achieved, that now rubidium atomic clock is there made by India only. Note. You can write one note, change the paragraph and write the note. And India has one more navigation system that is called GAGAN. You know, GAGAN is there. Now GAGAN has its own story. GAGAN is developed by ISRO and Airport Authority of India, and GAGAN's full form is GPS added. Geo augmented navigation. So India has got another navigation system that is called GAGAN. But in this GAGAN, GPS word is there. And I'm telling that even if the GPS word is there, this GAGAN has been developed by India. Now, why it is so? So I'll tell you one thing. GPS was developed in 1973. So in 1973, GPS was developed. America has developed it, right? So just go to the brief history of it, and I can tell you that here, GPS, USA, it was developed in 1973, right? But it was available only for defense sector, right? So it was only for defense. So GPS is owned by, listen very carefully, GPS is owned by American Defense Department, right? When America planned to develop GPS, America wanted to develop GPS for defense sector. America never thought that this GPS could be very useful in civilian application as well. In 1973, America wanted to have a satellite-based navigation system so that fighter planes of America can fly with the help of GPS. It can go to the target, it can bomb the target, and it can safely come back. America developed GPS so that American missiles can hit bang on the target without missing it. America wanted to develop GPS because American Defense Department wanted that American troops can navigate by using GPS and they will never lose their ways. So first thing you understand that navigation system, the first ever navigation system in the world was GPS, and that GPS was developed only for defense sector. Civilian applications were never in mind when it was developed. But what happened? What happened in 1983? In 1983, GPS was opened for civilian application, civilian or aviation, aviation, for civilian and aviation, right? So why sudden change, right? So GPS was for defense, but after 10 years of successful GPS application in American Defense Department, America decided to open a part of GPS for civilian application, right? Because what happened? A South Korean aircraft with passenger on board was flying over USSR. And due to navigation error, because around that time, aircrafts were not using GPS. So it was before 83 when GPS was never ever available for any civilian or aviation application. Right. So South Korean aircraft without GPS, because GPS तो था ही नहीं उस समय available, and this aircraft lost its ways because of some error, and it was flying over USSR in a no-flying zone. So USSR had a designated area that is called no-flying zone. That means countries' no-flying zone are basically sensitive area. And this sensitive area may be having defense equipment or something like border areas and something like that. So USSR shut down because USSR was not able to recognize, and South Korean aircraft was having some error in their own navigation system, in their normal navigation system that is there in aircraft, and they entered into restricted area of USSR. So USSR launched the missile and shot down the aircraft. And then they realized that this aircraft is a civilian aircraft. And they shot it down because this civilian aircraft by some error entered into no-flying zone. And then a discussion started all over the world that a civilian aircraft carrying innocent civilian can lost its ways, can enter into countries no flying zone, and that can be shut down. You got my point? And America has one technology that is called GPS, and American fighter planes will never lose navigation signal because they will have onboard GPS system which will communicate directly to the satellite, and they will get to know that where are they flying. Right? They will get to know where they are flying. So people requested America to open the GPS signals so that they can use it in aviation to make aviation more and more accurate, to make aviation navigation error free. And America agreed upon it. In 1983, America opened the GPS signals. Which signal? SPS signal, right? SPS signal. SPS, you know that SPS, standard positioning signal? So this SPS signal was available. So what signal was available? Standard positioning signal. So what America did, that America divided this GPS signal into two parts. Right. So GPS signal is also divided into two parts. PPS, precise positioning signal, and standard positioning signal. So from 1983, this tender positioning signal is available to civilian application and aviation application, right? Now I'll tell you, accuracy of GPS is 3 meter. That's 3 meter only. But in India, it's not so accurate. Not so accurate. It may go up to 50 meter, which is huge. So you just need to understand this basic thing. GPS was first developed for defense sector. Due to one air crash, America opened the GPS so that air travel and aviation can be made very secure to avoid such crashes. But the problem is, in Europe and America, the signal accuracy of GPS is 3 meter. That means if GPS is saying that you are here, the maximum you can be 3 meter around, right? So maximum deviation from the GPS location could be 3 meter only. But in India, GPS signals are not so accurate. It's 50 meter accurate. And obviously, America has opened GPS. America has opened the GPS in a goodwill. America is not binded. It's not binding on America to provide you free GPS. America is not having a compulsion of providing free GPS. You get my point? ये मामला वैसा ही है. मैं एक एग्जांपल देता हूं. तो गगन क्या है? Here I'm writing. So your GAGAN system is GAGAN is SBAS, that is satellite based augmentation system. So what does GAGAN do? It's an augmentation system. It's not navigation system. It cannot develop navigation signal, but it can improve the navigation signal already. Right. So आप लिखो, गगन पेलोड्स आर, ऐसे लिखो, सुनो, पहले तो ये लिखो, गगन इज ज्वाइंटली डेवलप्ड बाय, गगन इज ज्वाइंटली डेवलप्ड बाय ISRO and Airport Authority of India. Jointly developed by ISRO and Airport Authority of India. ISRO and Airport Authority of India. GAGAN is developed by ISRO and Airport Authority of India. Right. Next you can write. GAGAN does not require dedicated satellite. GAGAN does not require dedicated satellite. GAGAN does not require dedicated satellite. GAGAN payloads are placed in communication satellites. So that is another thing. So GAGAN payloads are placed in communication satellite. गगन के लिए अलग से सैटेलाइट लॉन्च करना नहीं है. गगन इतना बढ़िया है कि हम कम्युनिकेशन सैटेलाइट में ही लगा सकते हैं. So that is in communication satellite. You got the point? So there is no dedicated payload, satellite needed for the GAGAN. That is why we never see GAGAN satellite. So GAGAN payloads are placed in India's 3 communication satellite. 3 ही payload चाहिए और communication satellite में लगा दिया. और अब क्या करता है? This GAGAN system will do what? It will augment, it will add signal, right? Got the point? Next you can write navigation systems save time and fuel in different navigation systems save time and fuel in different transport sector, in different transport sector. Different transport sector, right? So you know that is why we use Google Map and all, so that we can save time and fuel, shortest and fastest possible ways it can search for you. Again, you can write one more point. Navigation system also helps in navigation system also helps in mapping and precise timekeeping. Navigation system also helps in mapping and precise timekeeping. क्योंकि एटॉमिक क्लॉक लगा है ना, तो मैपिंग भी करवाता है और टाइम कीपिंग भी. टाइम कीपिंग का मतलब क्या हुआ कि प्रॉपर प्रिसाइज टाइम कीपिंग कैन बी डन, राइट? टाइम कीपिंग, राइट. नेक्स्ट यू कैन राइट it also helps in resource management and disaster management. It also helps in resource management and disaster management. It also helps in resource management and disaster management. Resource management and disaster management. So you can write, it promotes tourism in remote area. It promotes tourism in remote area. It promotes tourism in remote areas. It promotes tourism in remote areas. Got the point? So this is how this navigation system work, right? और नेक्स्ट टॉपिक जो हम लोग डिस्कस करेंगे वो है एक्सपेरिमेंटल सैटेलाइट, एक्स्ट्रा प्लैनेटरी मिशन, राइट? सो हियर वी कैन गो विद राइट एक्स्ट्रा प्लैनेटरी mission. So when I say extra planetary mission, it is simply, we have three things in mind. We have done Mangalyaan-I, and Mangalyaan-I was Mars orbiter mission. It is also called MOM. What we call it? MOM, Mars orbiter mission. The second one is called Mangalyaan-II. So Mangalyaan-II, that is called Mars landing mission that we have planned now. It will be known as MLM. MLM. And the third one that we can talk about is Shukrayaan. Shukrayaan. That is called Venus orbiter mission. That we can call VOM. Right. Out of three, one is successfully done. So that has been done and successful. And these two in future. So let's complete this in future. So let's talk about this one by one. Right. So Mangalyaan is was our first extraplanetary mission, right? So I'll talk about Mangalyaan first. Mangalyaan 1. We launched it in 2013 by PSLV XL. So here we need to understand that we have launched it in 2013 by PSLV XL, and it was a grand success for India, right? And this was India's first extraplanetary mission with the main objective of remote sensing of Mars. So it was orbiter mission. It was like Chandrayaan 1, that we wanted to send something from Earth to Moon, and it will move around the Moon to do the remote sensing of the Moon. But then it was a big journey. Why it was a big journey? Because this time the distance that we wanted to travel was lot. This is Sun and this is Earth, and here this is Moon, sorry, Mars. So this is Mars. So what was the journey? That we launched it by PSLV. So PSLV launched the Mangalyaan over here only up to here. We have to go there, but it was launched here only. So from this point, you know that the concept of transfer orbit, you know. So we kept on circling around the Earth, and every time we increased the orbital height. So orbital height was increased, and then we entered into this area, and then we came to the lunar surface, very close to it. You get the point? So this is how we have traveled, and it was a long journey. It was a very long journey, right? It was a very long journey. Obviously, I'll tell you that PSLV will not be able to take it to the Mars, and Mangalyaan was there with a lot of fuel, and this fuel propelled Mangalyaan from the Earth's orbit to the Mars orbit through all these orbital raising and transitions. And it took great deal of time. It took months to go there, right? But we were able to do it. We were able to do it. Now these things are so technical that no country in the world could do it in a very first attempt. Any country who has done, they have done in the second or third attempt. The first attempt was failure to any country who have done it. But India, when India did it, India accomplished it in the very first attempt. And that made India first country in Asia to reach to the Mars. So first country in Asia to reach to the Mars. Although when India was planning this and India was sending this, I mean, developed country were not very happy with this misadventure, right? They were thinking that, okay, how can India do this? And that is at the low budget, because the budget of Mangalyaan was only 450 crores, right? So 450 crore only, right? So it was too less. American mission at the same time, NaVIC. So around that time, it was for India, Mangalyaan, the budget was 450 crore. And USA, NaVIC, that was a similar mission, was 4,500 crores. That was a difference. So all these countries, they were making, fun of India, that how India can do this. India will never be able to do it. India is doing misadventure. India is wasting money. None of the country has done it in a very fast go. Then how India can do it? And that is true with the 450 crore rupees mission. And America is sending 4,500 crore mission with the heavy payloads and lots many things. But India given befitting reply when we entered into the Mars orbit, and we became first country in the entire world to do it in a very first attempt and first Asian country to do it. So this Mangalyaan has given us so much of, respect, right? So you can write 1. Now, after Mangalyaan, we have already planned Mangalyaan-II. So we'll talk about Mangalyaan-II now. And you know that Mangalyaan-II is nothing but it's a landing mission. It's a landing mission. And once it is landing mission, then it will have components. And we all know what kind of components Mangalyaan-II will have. Right. Right. So in this landing mission, what is there? Originally we planned that it will have orbiter, lander, and rover. Yeah, that is what we have. But now, because we are nearing to this, so orbiter will not be there. At the place of orbiter, we are going to have helicopter like something. Now, how can we place helicopter? Because Mars have atmosphere. So Mars is having atmosphere. So once Mars is having atmosphere, so we can have helicopter, and this helicopter can bring this lander and rover to the place, right? So helicopter, why? Because Mars, here I can write, Mars has atmosphere. Here I'm writing, Mars has atmosphere, right? So atmosphere is there at Mars. Got the point? So that is one thing we should be knowing, right? So originally it was kind of, just similar kind of thing, but now it will be having a lander, rover, and an helicopter, right? Now, because it's a very early to say, it may be orbiter or maybe helicopter, right? Next you can write. Next point you can write. Next point you can write. The Space Commission approved Mangalyaan-II mission. The Space Commission approved Mangalyaan-II mission in February 2025. In February 2025, and Cabinet Committee has approved it in March 2025. In March 2025. In March 2025. In March 2025. Right. Next you can write. Next you can write. This mission will be launched. This mission will be launched with the help of LVM-3. This mission will be launched with the help of LVM-3 in next 5 years. In next 5 years. So it's not like we have any date. in next 5 years. Next you can write, Mangalyaan-II would make India. Mangalyaan-II would make India the third nation to achieve a Mars landing. 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 In bracket you can write, other nations are US and China. US and China. So till date only US and China has done it. So this Mangalyaan, if we are able to reach to the Mars surface, we are going to be only third country in the entire world to achieve it. US has done it, China has done it. But obviously we'll do that too. Don't worry about it. Right? So this is about Mars orbiter mission. Helicopter would be a unique thing because it will be doing direct landing onto the Mars, right? Like the helicopter lands, in similar way, it is going to be landing onto the Mars. But lots many things can change because the window is bigger. In the next 5 years, we are going to launch. So nothing can be said. Many things might change over the period of time. Here we can talk about Gaganyaan. Right. So Gaganyaan is basically one of the most, important mission for us, and that is nothing but the human space flight. So this is our human space flight of India. And under this flight, we will be sending. So we are sending human beings. So human crew, 3 human crew would be there, and they will be there into the orbit for around 3 to 4 days, maximum 1 week. They will do microgravity experiment and they will come back. So you can write. And you know that this Gaganyaan will be launched by modified version of LVM, that is called HRLV. Modified LVM-3. So HRLV is human rated launch vehicle. Human rated launch vehicle. Right. HRLV. So you can write Gaganyaan will be launched by modified version of LVM-3 known as HRLV. HRLV, right? Human rated launch vehicle. In this mission, 3 crew members will be sent in the orbit of 300 to 400 kilometer, 300 to 400 kilometer LEO, 300 to 400 kilometer LEO for the time period of 3 to 4 days. 3 to 4 days. 3 to 4 days. Full stop. Crew members will conduct microgravity experiments. Microgravity experiments in the orbit. Microgravity experiments in the orbit. And they will return back on the Earth. They will return back on the Earth in a capsule. In a capsule. Right? So this is what we have planned. So we'll launch these 3 people in LBM-3, and in LBM-3 there will be one capsule that will be known as crew module. We'll talk about that. This crew module is a place where 3 astronauts will be there. It's a secure place for them. They will go, and then this crew module will be ejected out of the LBM-3, and now this crew module will move around. LBM-3 will not be there. For 3 to 4 days, they will be there in the orbit, in the microgravity. They will do experiment. And then after this capsule will make a re-entry towards Earth. It will enter into the atmosphere. With atmosphere, it will have a lot of friction. Due to this friction, the temperature over the crew module would go up to 2000 degrees centigrade. But this crew module will have heat shield and protection mechanism. So the astronauts would be all safe, and then it will come very close to the Earth. Parachute would be open, and then it will splash down into Bay of Bengal. And recently, you know that very recently we have done first integrated airdrop test, right? Integrated airdrop test 01 was completed, and this airdrop test was done so that we can make sure that this crew module can be recovered or not. The parachute would open at the right time or not, it will recover or not, and it was done perfectly fine. So that is another milestone that we have achieved in the very recent time. In this month only we have done it, right? And if we are able to do it, then we are going to be only 4th country in this entire world to achieve this feat after US, Russia and China. So you can write one more point. Successful completion of Gaganyaan. Successful completion of Gaganyaan will make India. Successful completion of Gaganyaan will make India the 4th country after US, Russia and China. 4th country after US, Russia and China to achieve human space flight. So don't get confused with Rakesh Sharma and Shubhanshu Shukla. Rakesh Sharma was part of USSR mission and Shubhanshu Shukla was part of Axiom 4 mission. This will be independent Indian mission without any help. So India will also be in those list of elite countries who have done it, and India is going to be only 4th in that way. Right? But again, this is going to be a very dangerous thing. So we are not going in a one go. We are developing many new technology for it, and we are going to do it in a phase-wise manner. So in the phase-wise manner, 3 uncrewed test missions would be there. That is called G1, G2 and G3. 3 uncrewed mission will be sent, and it will have a robot inside that is called Vyomitra. You know about Vyomitra very well. And these 3 uncrewed mission would test all the key technology and safety features. And once we are doubly and triply sure about it, then only we will send the human being. So you can write, before human space flight, 3 uncrewed missions, 3 uncrewed missions are planned to test and verify, all the systems and technologies, of Gaganyaan, right? All the systems and technologies of Gaganyaan, right? So 3 uncrewed mission, and that will be known as, here we can write G1, G2 and G3. So the 3 uncrewed mission will be known as Gaganyaan-I, Gaganyaan-II and Gaganyaan-III, right? G1, G2 and G3, right? And G1 will be going in December 2025 with Vyomitra robot. So first of all, we'll send this, and after that, G2 and G3 will be also going. So Vyomitra robot, that we know. Once we have done this G1, G2 and G3, so once we have done G1, G2 and G3, then we'll send the crewed mission, right? Crewed mission, right? And then you can write next point. After successful completion of uncrewed missions, after successful completion of uncrewed missions, crewed mission will be sent. Crewed mission will be sent. Crewed missions. So now this will be what? Crewed mission will be sent. And these crewed missions would be having H1 and H2, right? So H1 and H2. Rather, it will be like, it will be known as Gaganyaan 4 and Gaganyaan 5. H1 and H2. Human 1, human 2. This is Gaganyaan 1, 2, 3, G1, G1, G2, G3, and that will be Gaganyaan 4 and 5. The code is given H1 and H2. This will be going somewhere. The date that has been decided is in 2027. So these are the timeline we are having. That's the mission plan. The mission plan that in Gaganyaan, 3 uncrewed missions will be going. That is Gaganyaan 1, 2 and 3. First of it will be going in December 2025. Vyomitra robot would be going. Once we have done all these 3 at the right way, then we are going to send the crewed mission Gaganyaan 4 and Gaganyaan-V, H1 and H2 in 2007. Earlier, the plan was two uncrew mission and one crew mission. But now these things have been revised. Now there will be three uncrewed mission and two crewed mission. So India is doing in a grand way now, right? Now, what this mission will have all together? So we know that if we talk about the payload of this mission, if we talk about main payload of Gaganyaan. So the main payload of the Gaganyaan will be two. The first payload will be known as crew module, and the second payload would be known as service module. And this crew module and service module will be together in orbit. It will be joined and it will be there in orbit. So this will be together known as orbiter module, because together it will be known as what? Orbiter module. So it will be plus, connected together. So it's like, it's like pen and cap. So pen and cap, like this is pen, this is cap. So two part will be attached to this. The both will move around like this. And then while returning, the service module will detach and only crew module will come, right? So crew module, you can write, first thing we can talk about crew module, and you can write, this is habitat of astronaut. Habitat means रहने की जगह. This is habitat of astronaut. This is very strong. This is very strong, thermally resistant module. Very strong, thermally resistant module with life supporting technology. With life supporting technology. Life supporting technology. Life supporting technology. Right. Life supporting technology. Got the point? Second point here only, in the crew module you can write, second point only you can write, in the crew module only. Crew module will also be used for, crew module will also be used for, crew module will also be used for launching and recovering the astronauts. Launching and recovering the astronauts. So astronaut would be there in the crew module while going up, and when they'll come back, the crew module is going to come down. The next one is service module, and you can write service module, and there you can write service module. It will provide necessary support to the crew module. It will provide necessary support to the crew module while in the orbit. While in the orbit. While in the orbit. Right. Now we have developed many things. We have done many important things to make this entire thing successful. Right. And what we have done, I'll tell you what we have done. So you can write, to make Gaganyaan successful, to make Gaganyaan successful, ISRO has developed and tested many key technologies and systems. Many key technologies and systems. Many key technologies and systems. Right. So many key technology has been tested, many key systems has been tested. What are those? We'll talk about it. Many key technologies and system. So give me what are those technologies that ISRO has developed and tested? So I'll explain few of them, right? So those key technologies are key technologies that ISRO has developed. One is called life support system. Life support system in crew module. So crew module will have life support system inside. So that we know. The second thing that we know, that is called pad abort system. I'll explain what is that. Pad abort system. Third one that we know is called crew escape system. Crew escape system. And the most recently that we have done is called integrated airdrop test. Integrated airdrop test. So that is called integrated airdrop test. So here we can write fourth one, integrated air drop test. That we call it IADT01. That was done in the last month only, right? This month only, I think. That was in August 2025. So very recently it was done. I mean, dates are not important, you know by now. So what is all these things that ISRO has done? And ISRO has done lot many things, but these are the main one. Light support system in crew module, because crew module will have, you know, when the crew module is coming down to the earth and it's just hitting onto the water in Bay of Bengal, then life support system for 72 hours would be there. That means the crew module will have enough thing to support the life of the astronaut for next 72 hours. Too much time, right? Pad abort system. Pad abort system says that if astronauts are about to launch from the launch pad, so if LVM-3 is at launch pad and if launching is about to happen, right? If the countdown, it is in the last stage, and then we realize that something wrong we can sense, then we can abort the entire mission onto the pad itself, right? On the pad itself, we can abort the mission, right? Because it's very difficult to abort the mission at the last, but we can do it. We can do it, right? That is called pad abort system. So last moment, if we could realize, and we'll have very robust testing mechanism as well, so that if minute problem is there, we can find it out. You know that when this Axiom 4 mission was going on and Shubhanshu Shukla was about to fly with the team members, ISRO scientists were also there. And there was a leakage from oxygen tank, right? And ISRO scientists were able to get that. They were the only who could able to get that. And then ISRO scientists, they communicated this to Falcon 9, SpaceX people. And they were not having, belief on the words of ISRO scientists. They were like, why are you wasting my time? And when they checked, it was the real thing, right? So that is what the pad abort system, right? So pad abort system means last moment checking of everything. And if something goes wrong, we will detect it and we'll abort the star system. Crew escape system. Even if the launching has been done, the rocket is going up. And even if the rocket is going up, it's still an atmosphere. And we realize that launching is not perfect. There is some problem in the launch. Even then, we can get this crew module out safely and we can recover and we can save all the crew members, all the astronauts. So crew escape system, that means after the launch also we can take them back if something goes wrong. And the integrated airdrop test, that means how we could deploy the parachute at the right time. And this splash down on the Bay of Bengal, that should be easy one, so that the people who are there inside, they should, come down with, comfort. There should not be risk. The minimizing the risk is thing. So we are doing the rest rehearsal for it. Okay. And obviously some countries are helping into this. So global collaborations are there. So you can write in Gaganyaan, in Gaganyaan, there are global collaboration. In Gaganyaan, there are global collaboration. There are global collaboration. Got it? What is the global collaboration? So you can write global collaboration, full stop. Initial training of the astronaut. Initial training of the astronaut was conducted in Russia. Initial training of the astronaut was conducted in Russia. Full stop. Whereas European Space Agency is providing infrastructure and rescue support. Infrastructure and rescue support. Infrastructure and rescue support. Right. Now, if we sum it up, then what are the mission objective of Gaganyaan? So, mission objective of Gaganyaan we can talk about. So, you can write heading mission objectives of Gaganyaan. Mission objective of Gaganyaan. Mission objective of Gaganyaan. And there we can talk about the immediate objective is to demonstrate. The immediate objective is to demonstrate India's capability to undertake human space flight. Right? India's capability to undertake human space flight. So that is one thing. The second thing that we can talk about, second point, in long run, it will provide foundation for space exploration, foundation for space exploration, foundation for space exploration, and human space program, and human space program, and human space program. Got it? So this is what we can talk about. Hello, and how are you? I'm Ritesh Rajaswal. Oh, I'm sorry. To PWIS. So today I am connecting. I'm sorry. So I got one video on. Anyway, so now we'll move on to the next topic, and the next topic is also a very, very important one. And that topic is, this topic name is Bhartiya Antriksha Station. Bhartiya Antriksha Station, BAS. BAS. You know that we have ISS, International Space Station, where Shubhanshu Shukla was there. But India has planned that India will have its own system. So India is going to have its own system, and that system would be Bhartiya Antriksha Station, right? BAS. By 2035, we are planning to have one, right? So we'll talk about that too, right? So what is the timeline? By 2035, that's a timeline, and this is going to be a modular space station. You know, space station means what? A space station is nothing. A space station is a kind of, place in the orbit where astronauts can go, they can stay there, they can do the microgravity, experiments, and then they can do all kind of job out there. So you can write, Bhartiya Antriksha Station, Bhartiya Antriksha Station is a planned modular space laboratory, is a planned modular space laboratory by ISRO. It will operate in low Earth orbit. It will operate in low Earth orbit. It will operate in low Earth orbit. Right. Full stop. It will have place for 3 to 4 astronauts. 3 to 4 astronauts. Full stop. It will offer ample space. It will offer ample space for habitation, experiments, and orbital operations. राइट अभी आपने देखा होगा कि अगर देखो इसमें क्या है ना, ये मॉड्यूलर है. मॉड्यूलर का मतलब क्या होता है? दैट इट विल बी कंसिस्ट ऑफ 5 मॉड्यूल्स. The module will be constructed one by one. We'll send the module one by one and we'll assemble it there only. So assembly will be done there only. Right. So you can write one more point. BAS, BAS, BAS will consist of, BAS will consist of 5 modules. 5 modules. 5 modules. Right? Comma. Base module, core module, science module, lab module and birthing module. Birthing means सोने का. Base module, core module, science module and birthing module. Right? Full stop. The first module, BAS 1. The first module, BAS 1, will be launched in 2028 by LBM 3. By LBM 3. 2028 by LBM 3. Right? So that is what we have planned. Okay, what kind of objective it will fulfill? So you can write BAS will serve as a research platform for microgravity studies, life sciences, medicine, earth observation and space manufacturing. Right. You got the point? So already we have planned that 2028 the first module will be going and full station operation will be achieved by 2035. Cabinet has already approved it, not a problem with that. And you know that we have also done something, because obviously there you have to, fix the module together. You have to, fix it together. That is called docking, space docking. So apart from this, we are already done one experiment that would come very handy in development of BAS. That is called a space docking experiment. So you can write. Right. Next paragraph you can write. SPADEX or space docking experiment successfully conducted by ISRO. Space docking experiment successfully completed by ISRO in 2024-25. In 2024-25 will play important role in development of BAS. So what we have done, this SPADEX was done with the help of PSLV. It was launched in December 2024. An experiment was conducted in January to March 2025. What is there in SPADEX? In SPADEX, there was two identical microsatellite. So we launched two microsatellite. One is called SDX01, SDX02. So there is one SDX. So we launched two things. Right. There was two things. Here I am writing. It was having two things. SDX01 and SDX02. What are these? These are the microsatellite. So here we had two microsatellite. I am writing here two microsatellites. SDX01 and SDX02. SDX01 was also known as Chaser. It was known as Chaser, right? And then another one was known as Target. So Chaser and Target. So Chaser and Target. It means, let's say I'll explain. So SDX02 was, I'll do the experiment in front of you. So let's say this is this you can see this is the white color, my earpods, right? And this is the black color remote control. You can see. So this earpod is Chaser 01 and this is your Target. So Target was here. So Target will be here. Target will not move. And then this Chaser will go and it will just attach with it. It will attach in such a way that the both will become one, right? And that is called docking. What we call it? Docking. So docking is done. So although it's all moving because it's in orbit, but this is Chaser. This all are moving. These all are moving like it's like this. It's moving, but this will be changing and attaching itself, and then they will move together, and then it will detach also. So we have done docking and undocking, right? So you go right. In 2025, docking and undocking was done successfully. So docking and undocking was done successfully, and India became fourth country. After US, Russia and China. To do a space docking and undocking. Space docking and undocking. So that is what we know about it. So SPADEX is going to be the one who will provide a lot of information to us, right? Okay, now we have done with this space mission, remaining part of the space pollution first. So remember, space pollution, NASA's big sky theory, up to that point we have written, isn't it? And after that, I mean, there was one person who was not happy with the NASA's big sky theory. So in 1978, NASA has given big sky theory, right? And in the same year, right, in 1978 only, from here we can write, in 1978 only, there was one more theory, and the theory was called creation of debris belt. Creation of debris belt by Donald, not Trump, Donald Kessler. Donald Kessler. So all Donalds are not Trump, Donald Kessler, right? So we are going to write from the yellow part. Get the point? I'll explain what is this theory. So basically Donald Kessler challenged this particular theory of NASA. He said that no, NASA's theory is not true because NASA is not talking about future. According to Donald Kessler, he said that after 30 years, 3 decades, the number of satellite will increase. What will happen? Number of satellite will increase in the orbit, and the orbit will start getting overcrowded. And at one point, the orbit can get so overcrowded that two satellites can collide with each other. And once the two satellites will collide with each other, then what will happen? It will, convert into thousands of pieces of debris. Big pieces and small pieces would come up. And one of the piece of the debris might go and collide with the other satellite. And then it will also convert that particular satellite into pieces of debris. Now these new pieces of debris can go and collide with yet another satellite. And then again debris will be created. And this way, what will happen? A chain reaction of collision will start. You know, chain reaction, one after other. And due to chain reaction of collision, what will happen? The entire orbit will convert into debris, right? And that will be known as debris belt. Debris belt. According to NASA, it's like if this is Earth and there used to be satellite everywhere. So satellite used to be there, right? What will happen? This will convert into debris belt. It will be having nothing but the debris. Why? Because after 30 years, many satellites would be launched and they can collide with each other, they can create some problem, right? So you can write in 1978, big sky theory was challenged by Donald Kessler. He proposed theory of creation of debris belt. He proposed theory of creation of debris belt. Full stop. According to this theory, after 3 decades, number of satellite in orbit will increase so high, that it will collide with each other. And a chain reaction of collision will start. Chain reaction of collision will start. Right? Full stop. The entire orbit will eventually convert into debris belt. Which belt? debris belt, right? So that was this big sky theory, and given by whom? Donald Kessler, right? So sorry, not big. अब आगे क्या हुआ? तो डोनाल्ड कैसलर की भविष्यवाणी सच साबित हुई. कब? 2009 में. In 2009, what happened? One American satellite collided with dysfunctional Russian satellite, right? So dysfunctional Russian satellite whose name was Cosmos, and then there was one American weather satellite that was Iridium. They both collided with each other, and all of a sudden, Kessler syndrome become truth, right? So you can write next paragraph. In 2009, a dysfunctional right. In 2009, a dysfunctional Russian satellite, collided with American weather satellite, and thousands of pieces of debris were created. Right. And this event was known as Kessler syndrome. Right? So Kessler's forecasting, Bhavishwani, that holds truth. You know that now. Right? So we have already gone through one major collision. And then we realized that it's a very important thing to look after. And not only this is not the only case. You know what happened? That many countries developed ASAT system, ASAT system. Right. What is ASAT system? That is called anti-satellite missile system. So anti-satellite missile systems are those systems which can kill the satellite of the enemy at the time of war. Right? You know that one more thing, that in 2007, China tested ASAT system. Right? And again debris was created. Right? So testing was done. In this testing, what China has done? China launched its own missile on its own satellite. So there was one satellite at the distance of around 400 kilometer in the space, and China shot it down just to show that China has ASAT system. You got my point? The second one was in 2019. I mean, if we talk about in 2019, India did the same thing. Same thing was done by India. And again, India did this ASAT thing, right? And there what happened? ASAT system, ASAT testing of India under Mission Shakti. We called it Mission Shakti, right? But then we had a very wise, planning, because we killed the satellite which are just 280 kilometer up. So at the height of 280 kilometer. And when the satellite is at the height of 280 kilometer, then what will happen? It will come to the Earth's atmosphere very soon, within 3 months only, and nothing will be left. But yes, technically, we also created some debris out there, right? Like China, like US, like Russia, they all have developed ASAT system, right? So that is another way that we can contribute and create a space debris. So you can write, in 2007, next point, in 2007, right, China created thousands of debris pieces during during demonstration of anti-satellite missile. Demonstration of anti-satellite missile, that is ASAT, right? Anti-satellite missile ASAT. Again, you can write. Next point. In 2019, under Mission Shakti, in 2019, under Mission Shakti, ISRO demonstrated ASAT capability, and a satellite was destroyed into debris. Right? So these two things we can mention, that how debris can be created by ASAT, and India has done its bit also. Khushbu is asking ASAT again. ASAT is anti-satellite missile. At the time of war, if some spy satellite is there, then India has got the capability to launch a missile to kill the satellite. So we have Prithvi missile designed for it, and we can launch a Prithvi missile to kill the spy satellite of the country, enemy country, right? So that is what we can do. Now, this is all about space debris and pollution. What we can do? What remedial action that we can do? What is the way to mitigate it? So mitigation of space debris, way out, that we need to talk about. So here we can shift to the next topic, and the next topic is, right, way to mitigate orbit or space debris. Mitigation. We are moving on to the next part, impact of ISRO, right? So first is impact of ISRO, and impact of ISRO on defense. So let's talk about impact of ISRO on defense, sector, right? So impact of ISRO on defense sector, that is what we can talk about. Okay. So you know that here the pointers would be there, because we have discussed so much into space that now only pointers would be sufficient to create the answer around, right? So because you have lots of data and the knowledge and concept, right? So that is what we are going to discuss in a point-wise manner. Now, one thing we should be knowing, everybody know about it, that nowadays we consider that space tech, when I say space tech is a dual technology. It's a dual technology. And what is dual technology? What does it mean? So any technology which can be used both in warfare and welfare is known as dual technology. So space tech will be used in both of the way, welfare and warfare. And when it is warfare and warfare, then this is called dual technology. So here we have to write the first point, right? That is dual technology. Space tech is a dual technology which will be helpful in welfare and warfare. We know about it. I'll explain. Welfare part you know. Very well, right? Because this space technology is giving us television program, educational program, right? It is connecting hospitals, it's connecting schools, right? It is playing very important role in disaster management, early warning system, weather studies, and warfare also we have discussed about it. It is a spy satellite. It can give you, look into the enemy radar and all, right? the welfare and warfare, right? So how it can be done? So the first thing we can write, that we know that missile technology is based on launch vehicles. Launch vehicles technology. Is there any problem? If you remember, I told you that India's first launch vehicle was SLV-3, and Kalam Sahab was part of ISRO around that time. And when India launched the first launch vehicle SLV-3 in 1980, Kalam Sahab was transferred from ISRO to DRDO. And at DRDO, the function, the work, the job of Kalam Sahab was to develop missile system, because he learned the rocket science in ISRO and replicated the same rocket science in DRDO, right? And I'll tell you one thing. On the basis of that, a missile development program was started, and then this missile development program was called IGMDP, 1983. So IGMDP is Integrated Guided Missile Development Program. And the missile that we developed, Prithvi missile, and we know that Prithvi missile was India's first ever missile, was based on SLV-3. It was based on SLV-3, right? And the most powerful missile Agni, India's most powerful missile Agni, it got inspired from first stage of PSLV. Which is PSLV. So you can imagine that India's first missile and India's most powerful missile, that is linked with launch vehicle. The first missile ever was Prithvi, and it was based on SLV. And then Agni missile, the most powerful one, right, is based on, and it is inspired from the first stage of the PSLV. You got the point? So that is what we have, right? Second point you can write that India is owner of satellite navigation system, right? Satellite navigation system. And the satellite navigation system of India is called NaVIC, right? So NaVIC is there. And you know that NaVIC is not only for civilian application. NaVIC has got both civilian and defense application, right? So it will have defense as well as civilian application. Right? So defense as well as civilian application. Got the point? So that is how the things are done. That is satellite navigation system, right? And we have talked about that in Kargil war we wanted to get, but we could not get it. But now we need our own, right? The next point you can add, like our remote sensing satellite. Remote sensing satellites like HISIS, like RESAT, like EOS. These are the satellites, and these are a spatial satellite. Why? Because these are either hyperspectral or it is active satellites, and these satellites can play a very important role in border surveillance, right? So that is important for role in border surveillance. Border surveillance, right? So that's play very important role in border surveillance, isn't it? Any problem with that? Right. So border surveillance is again defense related area. We won't say spy satellite, we won't use that hard word of a spy satellite, but still we can use the border surveillance word, because we are more about protecting ourselves. Yes, Anas. Agni 5 was launched, tested, right? Now we'll add one more thing. We know that another satellite that we have launched in 2019 was EMI-SAT. EMI-SAT. And like I told you that this EMI-SAT might have played very important role in this fight that we fought with Pakistan, right? So this is electronic surveillance satellite to detect radar activities. Very important one, could be very handy, right? Could be very handy, EMI-SAT. And don't forget that we are having defense communication satellites, like we have GSAT 7, we are having GSAT 7, we are having GSAT 7A, and now we are going to launch GSAT 7R and GSAT 7B. That is in future, right? That is in future, right? And all these satellites can play very important role, right? You can write it that this is for Navy and this is for Air Force plus Army. Till the time Army is not getting its own, Army is using 30% capacity of the GSAT 7A. You know it, right? Moreover, we realized one thing, that we have rivalry with China also, and China has already developed anti-satellite missile system. So for that we have to match the capability of China, and we have done it. So now we have our Mission Shakti, and we have also developed the ASAT system. So under Mission Shakti, India developed ASAT missile system. So ASAT missile system we have, right? We have ASAT missile system, right? But yes, after doing this much of the thing, but still we are not into space force. We are not willing to make any space force, like we have Army, Air Force and Naval Forces. But we are not going to develop a space force. But yes, we have something that is called integrated space cell. So integrated space cell is there, and this integrated space cell is being, it is being governed by Army, Air Force and Navy. And the function of integrated space cell is to keep eye on all the properties of India into space, all the satellites of India into space. And in case of any possible attack, they will try to reply back. They will try to save and reply back. So you can write. Next point. India has established integrated space cell. India has established integrated space cell to protect Indian Satellites and properties. Right. To protect Indian satellites and properties in a space. In a space from enemy attack. From enemy attack. This cell is being operated by all three wings of armed forces. All three wings of armed forces. That is Army, Navy, and Air Force. Right? So this is all about your space and defense integration. Got the point? So you have many points. So here we talked about 4 points and there we have 4 points. So 8 points are there. If they ask any question around main examination, you can easily write that. Now we are going to discuss about impact of ISRO on social upliftment and rural upliftment, right? So here we are going to get the next topic, and that is what? Impact of ISRO on either social or rural upliftment. Social and rural upliftment, right? Social and rural for India you can use interchangeably, because we know one thing, that in India the society means that in a rural area we have it, right? So there is not a problem, you know it well, that it's not a problem anymore, right? So society, and you know that there is a concept like India and Bharat. So Bharat is your rural India, right? And you know that whenever we talk about upliftment, we need to uplift the last man of the society, the last person of the society. The last person of society is much below the poverty line. He or she is not having all the means that we are having in our home and around us. And this last man of the society is not living in any city. You don't see those people in city. If they are in city, they are there for only job. They belongs to the village. They belongs to the rural part of the India, right? And the last man of the society is, 99.9% cases, it's in rural part, right? Got the point? You know that we always follow Gandhi's philosophy whenever it comes to implementation of any welfare-centric activity. And Gandhi's talisman, you know that Gandhi's talisman? On NCRT books, it's written that Gandhiji has suggested that if you take a step and that a step is not being beneficial to the last person of the society, then the step that you have taken is not right. It's wrong, right? So now we'll understand that how this social upliftment and rural upliftment can be done and what ISRO has contributed into it, right? So first thing, here we need to understand, now this is not science and technology, this is very much common thing. So one thing, that is knowledge enhancement technology. So the first point you can say that knowledge enhancement technology. Knowledge enhancement technology. Knowledge enhancement technology. Right. You know that knowledge is very important. Knowledge is not like the knowledge that I'm imparting to you. It's not knowledge, it's basically study. Knowledge is about that students should get knowledge about the higher study. The students who are studying in the college, they should have knowledge and awareness about what kind of job they can get. The farmer should get knowledge and awareness about their farming, Fasal Bima Yojana, Ayushman Bharat, right? A citizen should have knowledge and awareness about the elections which are going on, right? All the beneficial missions and projects that can help them, right? That is what we talk about. So knowledge is basically it's about awareness, right? Awareness. The knowledge that we are talking about is study. So here you know that one of the biggest knowledge enhancement technology is DTH or satellite television. So DTH or satellite television is very, very strong medium, and that is not only entertainment, this is infotainment, right? Infotainment, you know that? Information and entertainment. That's the concept, right? And apart from this, we are having VSAT application. You know VSAT? VSAT applications are there. And on this VSAT applications, what we do, we provide education and training to the rural area. So education and training to rural area, right? Because rural area will not have the vocational training and education setup which are very robust, right? And then this can do the magic. The VSET can do the magic. Education and training. Got the point? Right. Now, you know that this knowledge enhancement technology can also provide information in agriculture sector through various channels. Like channels like we have Kisan television, we have Kisan call center. And you know that whenever we talk about information technology like Kisan television, Kisan call center, it is linked to the satellite also. Because any information technology will have linkages with the space technology. So here we can also write third thing, Kisan television and Kisan call center. Kisan call center, right, for agri sector. So our farmers will get information from here. This is about knowledge enhancement technology, and this is how everybody will get information about it. Student will get information about their education and job possibility. Citizen will get information about their rights and the welfare schemes that they have, right? So that is how. Next point you can write. Next point. So 3 points we have written in this knowledge enhancement technology, and then you can sum up. Paragraph change and impact of ISRO on economy, right? So economic development, how economic development can be done, right? So the first two things you should understand, two things, right? First thing, that according to the principle of economy, if you develop very robust infrastructure, then based on that infrastructure you can have many economic activities going on, and more economic activity will give you more revenue, more job opportunity. Same thing India has done. ISRO once decided to launch many communication satellite, and many communication satellite means that we created a very robust communication infrastructure in the sky, in the space basically. And based on that infrastructure, many company in India came forward and they started rolling out lots many new services like DTH and satellite internet and lots many things, right? Like I told you that Tata Sky was the only one around that time and DTH was not so popular. But now DTH is very popular. And just you think about DTH. Every one of us are having DTH connection at our home. And how big the DTH market is. Lakhs of people are employed into DTH only. Imagine if satellites were not there with India, it would have not been possible to create a DTH infrastructure in the country, and it would not have created so many of job opportunity as well, right? So you can write. First point, ISRO has developed robust communication infrastructure in space. ISRO has developed robust communication infrastructure in space by launching communication satellites. By launching communication satellites. By launching communication satellites. By launching communication satellite, which helped in establishment of many new sectors and industries. Many new sectors and industries such as DTH, VSAT services, satellite news, satellite internet, etc. Satellite news, satellite internet, etc. Satellite news, satellite internet, etc. Right. All these sectors, you can write, all these sectors have generated a lot of employment opportunity, and revenue in Indian economy. Yes, DTH and D2H एक ही है. D2H is Videocon का service D2H है. Overall it's DTH, right? So one simple theory is there that you just do nothing. You do just one thing, that you create infrastructure. On that infrastructure, lot of activity will start, and this activity will generate revenue as well as employment. And you know that revenue and employment are two major pillars in the economy. Similarly, that is about communication satellite. The second point we can talk about, the first point was done, that is communication infrastructure, right? Infra. The second thing about remote sensing. You know, the second thing that we can talk about, that remote sensing satellite, they can help us to, manage the resources. And better management of resources may lead to more productivity and more benefit, more economic benefit out of it. So you can write remote sensing satellites play important role. Remote sensing satellite play important role in management of natural resources and development of modern infrastructure. Management of natural resources and development of modern infrastructure. Right. For example, mining, right. For example, mining, agriculture, fishing, mining, agriculture, fishery, road development, rail network development, rail network development, and other infrastructure development. Right. Now you can write paragraph change and you can write in this point only. Better management of resources. Better management of resources will lead to better productivity and more economic gain right. Whereas modern infrastructure creates new job opportunity. Right. Like we have road. So once you make road in a village, Pradhan Mantri Gram Sadak Nirman Yojana. With this Yojana, you just connect the village to the district highway or a state highway. And once the road is there, that is enough for good economic activity in the village. The single road can change the fate of the village. A student will be able to travel to the nearest city easily for higher education. Youth will be able to travel to the nearest city to get the better job opportunity. Farmers will be able to go and sell their product into the big market to get the good price. Some people in the village will start, transport business. You get the point? Like small vehicles, and they will be ferrying the people here and there, right? And then to drive this vehicle, you need to have driver, you need to have mechanic. So what will happen? All these job opportunity will be created at the rural level and the village level, and people from the village will get opportunity out there. You get the point? So in that way, you will have to think. You will have to connect lot many things together, right? So that is two very important things, right? Now you know that these are the two main points, but the third point is called a space industry cooperation. A space industry cooperation, because many technology that has been developed in a space sector initially, after many years, it might get transferred to the industrial aspect. Right? You get the point? So, from a space, it can come to industry. And if any technology is coming to industry, the industry will grow. And if the industry is growing in India, it will have global presence and will attract more money and more business. You know that ISRO is providing around 650 such technological cooperation with different industries. So ISRO scientists go and they give the expert view. They give some technical view onto that. So you can write under a space industry cooperation, there is space industry cooperation. Many advanced technology of a space sector are being used for different industries in India. Different industries in India. ISRO is already providing technical consultancy services. Technical consultancy services to more than 600 industries. To more than 600 industries. To more than 600 industries. Right. So that is what? If industry is getting benefit. Next one. Next point. So next point that we can talk about, that ISRO's commercial venture. You know that? So you're right. ISRO is selling. हाँ, मेंस से रिलेटेड टॉपिक है ना, तो लिखना थोड़ा पड़ेगा, because these topics would be coming in the mains examination. Right. ISRO is selling its launching services, remote sensing data, and satellite technology in international market. And generating revenue for itself. Right. So that is one thing. So ISRO is generating some revenue for itself. ISRO is eyeing on the big billion-dollar space industry, and we are getting our share. We talked about that we have launched more than 400 satellites of 34 different countries by the PSLV itself. We are selling remote sensing data. We are selling satellites. We are selling whatnot. Right. So these are the things that is economic development. I mean, economic part of the ISRO is important one. That is why ISRO decided to promote its economic activity long back. And in 1992, ISRO started its commercial wing. Commercial wing means ISRO's shop, ISRO's commercial establishment. That is called Antriksha Limited, right? Antriksha Corporation Limited. So you can write to promote commercial, next point, to promote commercial activities of ISRO. To promote commercial activities of ISRO. That is the fifth point. To promote commercial activity of ISRO, there are two commercial wings. There are two commercial wings. No heading, nothing. It's just running. There are two commercial wings. First is Antriksha Corporation Limited. Antriksha Corporation Limited, 1992. Antriksha Corporation Limited, 1992. Antriksha Corporation Limited, 1992. That's the first one. Antriksha Corporation Limited, 1992. And we can write just one point about it. This organization, I repeat once again, to promote commercial activity of ISRO, there are two commercial wings. There are two commercial wings. There is no fourth point heading. It's just point. Point tha, ISRO is selling its launching services, remote sensing data and satellite technology in international market. That's it. Heading क्यों चाहिए? चलिए. Now the fifth one is not having heading. It's again running text. And to promote commercial activity of ISRO, there are two commercial wings. One is Antriksha Corporation Limited, 1992. This organization deals with consultancy services, remote sensing data, consultancy services, remote sensing data, consultancy services, remote sensing data, and launching services. Right? Launching services. So that is Antriksha Corporation Limited. Right? If you go to the Bangalore, the city Bangalore, so there is one called Antriksha Bhavan. It's a ISRO setup, Antriksha Bhavan. And in Bangalore only, the Antriksha Corporation Limited is having its headquarters. Right. NSIL, that is called NSIL, the second commercial wing. New Space India Limited. Right. New Space India Limited came in existence in 2019. So that was in 2019. Right. So this is a new commercial wing of ISRO. And this new commercial wing is doing magic. They are doing lots of wonderful job. Right. The wonderful job means that they are basically, right, this is basically for private entry of private sector into the space sector. And then it's a new Space India Limited. That means new outlook, new way, new commercial aspiration and everything. So you can write, this is enabling Indian industries. This is enabling Indian industries and private sectors to participate into space related technologies and activities. The organization is doing, and that is what they are also bringing a lot of foreign and international business to the ISRO. So their outlook is to get the international business. So you can write one more point. NSIL is promoting ISRO's services and products. NSIL is promoting ISRO's services and products in international space market. In international space market, right? International space market. Full stop. Many recent international launches. Many recent international launches were managed by NSIL. Were managed by NSIL. Were managed by NSIL. Right? So this is what we have in this, and we are left with just one topic now, right? Because obviously ऐसा लगा होगा आपको कि लेंदी है, but this is very important one, because if UPSC ask any question in main examination, right, then what will happen? You will have to write some of these points. UPSC mains question, you know, na? They always link it with the society, economy, development. So for that you need to know.